Hey guys, Mr. Backerberg here. In this video, we're going to look at Newton's law of cooling. An object that has been heated will cool to the temperature of the medium in which it is placed. So that could be the surrounding air, or you could place it in some water. Now, in our formula that we're going to use to model the temperature, this capital T is going to represent the temperature, and this lowercase t is going to represent time. So this is the temperature based on a time. And what we do is we take the temperature of our medium, so whatever we're placing the object in, plus we take the initial temperature of our object minus the temperature of the medium, times E, and then we're going to take that and raise that to the power negative kT. And this is Newton's law of cooling. So we've got a hard-boiled egg at a temperature of 96 degrees Celsius, and we're going to place that in some 16-degree water to cool. Now, 4 minutes later, we measure the temperature of the egg, and it's at 45 degrees Celsius. We want to use Newton's law of cooling to figure out when the temperature is going to reach 20 degrees Celsius. So based on what we know is this egg was heated up to 96 degrees Celsius. So that's going to be our initial temperature. That's going to be our T sub 0. Now, as far as the temperature of our medium, it says that we're putting this in some 16-degree water. So that's going to be 16. So if we take the information that we've got and plug that into Newton's law of cooling, let's say the temperature based on our time, well, the temperature of the medium is that 16 degrees, plus we've got our initial temperature minus the temperature of that medium, and we're going to take that and multiply that by E raised to the power of negative kT. Now, inside of our parentheses, we can simplify that down. So that's going to be 16 plus 80 times e to the negative kT. Now, based on some of that information that we know that after 4 minutes the egg has cooled to 45 degrees. So we can actually take that and plug that in to help us figure out what our K value is going to be. So this temperature on the left-hand side, that's where we're going to plug in the 45, equals 16 plus 80 e to the negative k. Now, as far as our time goes, we know that that's 4 minutes, so we can plug in 4 there for our t value. So it's k times 4. Now, we're trying to solve to figure out what k is. So the first thing I'm going to do is subtract this 16 over to the other side. So we're going to get 29 equals 80 e to the negative 4k. And then I'm going to divide that 80 over to the other side. So we'll get 29 over 80 equals e to the negative 4k. Now what I'm going to do is write this in logarithmic form. So this is going to be log base e of 29 over 80 equals negative 4k. Now log base e is a natural log, so this is the natural log of 29 over 80 equals negative 4k. Then I'm going to divide that negative 4 over to the other side. So we're going to get a k value of the natural log of 29 over 80, all divided by negative 4. Now when we type all of that into our calculator, we should end up with a k value of about 0.2537 approximately. Now that we know what our k value is, we can use it to help us figure out our original problem, which is trying to figure out when the temperature of our egg is going to reach 20 degrees. So on the left-hand side of my cooling formula, that's where I'm going to put the 20, because that's the temperature we're trying to reach, equals 16 plus, when we simplify down the stuff inside of the parentheses, we know that that's just going to be 80 e to the negative 0.2537 t. Now I'm going to subtract the 16 over to the left-hand side, so we're going to get 4 equals 80 e to the negative 0.2537 t, and then I'm going to divide the 80 over to the other side. So we're going to get 4 over 80 equals e to the negative 0.2537 t. Now we're dealing with an e exponential, so we're going to turn this into a natural log. So this is going to be the natural log of 4 over 80 equals negative 0.2537t. And then I'm going to divide that negative decimal over to the other side. So we're going to get a t value of the natural log of 4 over 80, all being divided by negative 0.2537. And when we type all of that into our calculator, we should get about 11.8. Now we're measuring this in minutes, so it's going to be 11.8 minutes. Now if I wanted to convert this into time instead of just being 0.8, what I would do is I would take the 0.8 times 60, since there's 60 seconds in a minute, so we'd get 11 minutes and 48 seconds. That's going to be it for this video. Thanks for watching.